So, now I know why people make ASMR channels on YouTube. It's hard not to. I mean, how the hell how do I get this microphone to record me at a decent volume without you picking up all the eating noises and slurping noises and things like that? I don't know. Breathing noises. So I'm going to try to keep that to the minimal, but I apologise if you do hear anything of that nature. I was just wave shaping. Yeah, so there we are. There is our current state of play with the synthesizer. And welcome to this next chapter where I will be starting to shape the volume with an envelope shaper, so we can get an instrument sound. However, before that, a bit of housekeeping. I want to use a feature that's available at least in Purr data. I think it's a bit more complicated in pure data, and this is one way that Purr data is a little bit easier than the other versions of pure data out there. But it's called encapsulate, which means we can take a bunch of these components, wrap them up into a box or a separate component, so we don't have to think about them, and we can in fact reuse them in various places. But before we do that, a little bit of housekeeping here. So I'm going to pull these together. I'm going to get rid of that. Some of these diagnostics won't be so interesting when they're wrapped up in a component. The same with this. But I want to change this. Here we've got a pitch control, and the pitch value is being used twice. It's being used to set the fundamental frequency of the synth, and it's also being used in this connection to control the ratio, or fed into the ratio with the ratio into the frequency of the modulation oscillator. And I want to make this a single connection out of the pitch slider. So I'm going to delete those two connections. I'm going to create just a simple get rid of that. I'm going to create a simple number box here, and the number box will feed there. It's going into the main thing, and here it's going into the second oscillator. So now we have a single connection coming out of our pitch, so our component doesn't have to have more inputs than it needs. Up here, or down here, so across here, we have the same problem where our wave shaper, again, we will get rid of this. That was just an illustrative, we don't need that now. But we do have three values coming out of that, and I'd like to make them a single one. So this wave shaping parameter we will consolidate into a single number box, which will feed both the maximum of the clipping. It feeds the multiplied by -1 to get the minimum of the clipping, and it feeds this power to the -1 that gives us our value to amplify to compensate for volume lost to the clipping. So, and I will pull those up here a bit more. So we still have the same, the behaviour of the synth hasn't changed, we've just refactored it. Put the volume up, still does what it always was doing. can now do is we can trigger this, we can highlight, grab all this, and we're going to wrap that up, encapsulate it into a single component with this encapsulate button, and we're going to call it FM voice. So this box here has everything that we have just hidden away in it. It's got 4 inputs. The first input is the pitch control. The second input is the amplitude. I'm not quite sure. I mean, it had its reasons for doing it that way. So the amplitude is the second input of the FM. The ratio is actually the fourth input, and the wave shaping is the third input. So it did that automatically, and that will work for us. So that's it. I'm going to finish this video here to make sure it was okay, and then we will move on to the envelope in a second. Welcome back, and we now have the soft pattering of rain outside, which I hope will add extra relaxation to your synth making experience. So let's get on with the volume envelope control. So we want to shape the volume of our voice. Remember, we've now packaged a lot of the components up in this FM voice object, and we just have these 4 controls outside. So we want to take this connection, we want to now shape the volume. So we shape volume, of course, with an amplifier, which in pure data is always just a multiplication. But the multiplication is going to take the audio signal on one side, and the other side is going to be fed by something which can create the shape of our envelope. And the object which creates envelope shapes in pure data is called a V-line. A V-line tilde because it's working at audio frequencies potentially. And its output is just going to be a value which we can multiply, and over a period of time that value will change. That's the shape. This is the part of our envelope generator, this which will feed this, which we could think of as the equivalent of a voltage controlled amplifier. So what tells the V-line the shape of the envelope? Well, it's something here called a message, which is like a little program or a little package of data in the right format. And the right format for a V-line is a number of stages, and we'll put that here. Okay, so we're going to make a simple envelope, and the simple envelope is going to be, let's do the really simple envelope first, right? Make a message like this, and we're going to go from 0 to 1 in 100 milliseconds, and then we're going to go back to 0 again. This is the decay stage in 400 milliseconds. But it's important to note this first stage starts immediately. The second stage, we only want it to start when the first stage has finished. So we will wait 100 for the first stage, the attack stage, to finish before we play this decay stage. So if we now put that there, we can actually click on a message to fire it off. So if you see now our volume, well, in fact, you're not hearing anything anymore because we have this amplifier is at 0. But if I click this message, you now hear. So the message encodes in a particular format the right data to be sent to the V-line. And that format is, let's make it a shorter attack, for example. Let's make it only a 30. attack, and perhaps we can make the but of course I have to change this now to start the decay immediately after the attack finishes. Still quite long. Let's make a really short attack. Let's make an attack of 4 or 3. 4. And of course we only wait for 4 here. So it's more pingy now. Okay, so what we actually want to do though, of course, is control this envelope not by having to go into edit mode, but make some sliders. So the first thing we will do is we will add these new sliders. We'll make a slider here for the attack. We'll call it attack, and we will give it between 0 and 300 milliseconds. We'll give it a box so we can see what value it's got here. We will make a second slider for the decay. Give that a box as well. Go to properties. Sometimes my mouse is a bit, doesn't want to behave properly. Okay, we'll give this between 1 and 0 and 1,000 in fact. So we get a range of decay values. Now, we need to get these two values into this message. And there's a particular way of doing this. It looks a bit convoluted initially, but it's flexible and it makes sense as a more general purpose mechanism in Purr data. So the first thing we will do is we will edit this message and we will replace the values with slots. Slots are like a bit like variables in a programming language, but you can think of this whole message as almost like being a piece of XML or JSON if you're used to programming. They're structured fragments of information, but this one is like a template. We can fill the slots with some values. So here I'm going to call this slot $2, and I'll explain why 2 in a minute. That first item is a constant. We always want to go to 1, so we're not going to change that. The same here. This third item is 0. We're always going to silence. Here we are going to put a slot called $3, and then again we're going to finish after $2. So we're going to start this after $2 if you remember. The attack starts immediately, it goes to 1 over a period of milliseconds stored in this slot 2. The decay goes back to 0 over the period of milliseconds stored in $3, but starts only after $2 milliseconds. So now all we need to do is get the data from the sliders, the attack and decay sliders, into these slots. And the way we do that is with an object called pack. So a pack object takes in multiple inputs, and when it's triggered or when it's fired, it packages them all up, the multiple inputs in parallel, into a package of data and sends it out of a single channel. We need to tell it what format we're using. Excuse me. And we will actually have a format where it takes 3 floating point or real number inputs. All the numbers in Purr data are floating point, meaning that they can be 0.6 or something as well as integers. And so this pack object, we've defined its format as being 3 numbers. We're now going to take the value of the attack slider and put it into the second input, and we're going to take the value of the decay slider and put it into the third input. Now you might understand where this $2 and $3 come from. When this pack packages up the data and sends it, it's going to be in this form of like slot 1, slot 2, slot 3. This message now is going to pull the data out of slot 2 to fill this bit of itself, which describes the time that the first phase is going to take. Similarly, this will take the item $3, the third slot in this package of data, and of course this takes the second. Okay. Well, why 3? Well, because just like in in an ordinary synthesizer, you'll have MIDI on. You have to sort of send the note on message, or in a modular synthesizer, you've got to send the trigger event, which says start this going. You'll have a gate, and you'll fire a pulse through the gate, or a trigger pulse through the gate. In pure data, these objects always activate or are fired when something comes in on this what we call the hot input, the top left hand input. Now, we do not want our envelope playing a new note every time somebody changes the attack or changes the decay. Okay, we want this to fire when there's a note on information. So the attack and decay have to be coming into cold inputs, these ones over here, and we want a specific event to come into the hot input, which will trigger this to act, packaging up the data. That triggered package comes down to here, that formats it into the appropriate message, that comes down to here, that triggers the V line into starting the envelope, and the V line then goes through and does the whole envelope. So we have to trigger it, and the thing that triggers these is something we call a bang. A bang is just the equivalent of any button being hit or any sort of event that makes something happen. Note on, gate trigger, whatever. So we'll put the bang into the first item of the pack. It's got to be the first one because that's the hot item, and we want the hot input, and we want the bang to be the thing that sets this whole process off, that starts the envelope. Because it's one of the inputs of the pack, although that's taken up our first slot of our pack, so that's why the pack needs 3 inputs, 1 for the bang and 2 and 3 for the actual data we're interested in, which is coming in from the attack and decay sliders. So let's hear how that sounds. We need to now give it a bit of an attack and a bit of a delay, and you can hear, if we give it a long attack, if you give it a long delay. So we now have our, and let's put the attack down to a short one. Let's make the attack very short. When you start to listen to this, you can now, I've got this wrong way around. I want my ratio here, and I want my amplitude up, and I want my wave shaping. Right, you can start this sense of FM synthesis and the metallic nature. It really becomes clearer and more obvious when we are working with these shaped sounds. Now it really sounds like someone tapping a bell, or and you get that slightly detuned metallic sound. Now these waves have not changed at all. If I was to just connect that back out, bypass the, it's the same thing you've heard before. It's just that sound, but coming through the envelope. gives it a much stronger sense of and we can bring this up, the wave shaping, to make a sort of cracked bell sort of sound. You know, we're getting some quite surprisingly realistic sounds now for a process which is for a process which is very electronic. We know we just built this out of sine waves and a bit of distortion or clipping, but it really gives us that dull metallic bell type sound. So that's where we're finishing this part, and we will move on to adding one extra feature to our envelope in the next one. Thanks for watching.